So welcome all. This is our entry for ArangoDB QGraph challenge. Our app name is ArangoMedica, ArangoDB powered medical AI. Imagine a medical AI that is able to take decision on its own, does some intelligent analysis, smart calculation, and does work on the medical data. So that's our application. So the problem that we are trying to solve. ArangoDB powered AI agent is solving a graph based medical intelligence problem where patients, diseases, symptoms, and treatments are interconnected. Our AI can analyze this relationship to provide insights like finding the most critical symptom for a disease, example, hypertension, asthma, predicting potential diseases for a patient based on symptoms, finding treatment that works best for certain diseases, identifying patients at high risk based on co-occurring symptoms, detecting hidden patterns in medical data using graph analysis. Why did we create the synthetic data? So the synthetic data allows us to simulate real world medical graphs. The relationships that we made was very realistic. We can test AI algorithms at scale, develop a working prototype that can be later integrated into medical data sets. So first we persisted the data. So data, we had like a small batch of data that was sent to the ArangoDB cloud instance, and finally, when we checked the entire shape of the data, we checked like it has got 9,409 nodes and 1,97,116 edges. So this is a subgraph visualization of the graph that we created of the data set. So meet our AI agent. So what is so special about it? First, it reads our question, breaks it into smaller tasks, fetches data from the database, runs a smart algorithm to find the answer, explains the result in simple terms. Now, why is it powerful? It automates complex graph analysis, no need for human expert. It works dynamically, it figures out the best approach based on our question. It's explainable, the AI tells you why the answer makes sense. So the solution that we provide consists of AI tools that has got simple data retrieval for text to equal to text. Example, find all patient diagnosed with diabetes using ArangoDB queries. Then we have graph analysis, algorithm analysis. Find the most influential disease using PageRank. We use network X algorithm, combining both database and graph analysis. That is a hybrid query, identifying the most common co-occurring symptoms for heart diseases using both AQL filtering and network analysis, extracting a subgraph, then the visualization part. So hybrid query mode, what is so special about it? ArangoDB equal for structured graph database queries, network X for graph analytics, GPT-4 for reasoning and query interpretation. So there is so much nesting in this hybrid itself. So we go to the demo. We have two demos being created with two different AI agentic framework. One is OpenAI agentic integration with LangChain and LangGraph, and the next one is Microsoft's AutoGen framework. So let's see it in action. So here we have the first demo with the LangChain implementation. So let's take a look at some of the queries that are formulated. So we'll check on that. So let's go to this part where we have this question like translate this natural language query into AQL, find all disease treated for drug aspirin. So if you run this, you'll see the entire process. It gets into the Arango graph QA chain, it gets the information, then there is a chain is finished, we get the results for this. The drug aspirin is used to treat the following disease: pneumonia, asthma, diabetes, and hypertension. So how easily it went through the Arango QA chain and pulled in all the information. So let's just have another query like extract a subgraph of drug, disease, symptom, and treatment. So if you run through it, you will see like again it goes through the entire the tool chain, and intelligently it uses the AI based agent tooling system, and it tells that the subgraph has successfully extracted 41 nodes and 92 edges. Okay, so now we will visualize the between values for a page and also the PageRank values for subgraphs of diseases, symptoms, and treatments. As we pass in the information, as a query parameter and we run through it, you will see the information like the results in action over here. The query is being run. It takes some time, like the step, and you will see the entire the visualization is being created for PageRank as well as the betweenness of the graph. Okay. So now we ask another question, like who is the most popular person in the graph, and explain why. So if you run through this, you'll see again the graph goes through all the details. It uses the LangChain as well as the entire AI agent logic, generate the network X code. It's generating the network X code on its own. Then we find the details of it. Finally, it gets the information, and as you can see, like the most popular entity in the graph according to the PageRank algorithm is a node with ID medical this, which is classified as a symptom. It has a PageRank score of approximate this, and is considered the most popular due to the PageRank score, which suggests it is well connected with the graph. This means it is likely how many incoming connections from important nodes, indicating a significance or influence in the network. So this is another query that we are passing, that most influential symptom among patient diagnosed with diabetes using PageRank analysis. So if we pass through it, you will see like it goes to the entire information base. It creates the ArangoDB QA chain and retrieves the information. It goes to the Arango QA chain, put in the equal results for this for diabetes, like it has got the information. Then finish chain, blood, vision, fatigue, this information is there. Then it generates the network X code. Finally, the analysis identified several symptoms commonly associated with patient diagnosed with diabetes. Cough was highlighted with the PageRank value of this. This suggests that while cough is not most prominent system, it still holds the information. Now, let's take a look at one of the hybrid queries, like find the most common symptoms associated with disease asthma. So if you run through that, you will see like it chains through lot of depth in the AI tool and gets all the logic working together as a unit to get our result. So first it executes the equal query, enters the auto ArangoDB QA chain, it finishes the result. Then again it generates the network X code, it gets the information and gets all the values for this. Then you see like it goes through the results of that the entire information and symptoms associated with disease, asthma, cough, chest tightness, wheezing and all. So these are the results that we see from the entire thing. And now let's take a look at our AutoGen framework. So for AutoGen framework, what we did was we installed some important libraries, like this one, what we see like AutoGen agent chat that was installed. Again with that, we installed the AutoGen framework and we initialized all the tools that we created and we passed in the system prompt and named it as an assistant agent type with graph assistant as a name. We have given all the details. Now let's see some of the queries in action. So this query, it's a similar query, find all diseases treated by drug aspirin. If we run through this, it goes through the selected tool that is text to equal to text. It goes through the Arango QA graph QA chain. Then we ask this, we visualize the betweenness values and PageRank values for subgraph of disease, symptoms and treatments. It checks and it selects the visualize matrix tool and creates the entire result for us. Similarly, if we have this most influential symptom among patient diagnosed with diabetes, so if we run through it, see like it goes directly into the hybrid query mode. It goes into the Arango QA chain, gets information, for the entire results like blood vision. Then it generates the network X code. And finally the response that is given. Now let's take a look at list another query, that is list recommend treatments for disease tuberculosis using equal. So if you run through that, you will see the results in action. Okay, so that's all about our application. Hopefully you liked it. We covered lots of aspect of ArangoDB and it was fun. Thank you.